So back again with radicals. Radicals are different from what we've been doing with the positive and the negative charge. Every time we used an arrow, a full-headed arrow, we were moving two electrons. That's why the full-headed arrow was used. It's stating that we're moving both of them. So now, since we only have one electron, this would now make sense in why we're using a half arrow. Now, this is going to be a little bit different because we're also using 3 arrows in this case, so you really have to just take your time. But the great thing is the snapshot method still works. 1, 2, 3. So again, wherever your radical is, that's going to be considered number 1. Then 2 is the start of your double bond, and 3 is the end of your double bond. It will always be in this method, even if you go back to the previous videos, same idea. So the issue is we're moving half at a time. So if we're moving half at a time now, it's like you have to conjoin and make a new double bond at the same time breaking the other double bond. Seems fairly similar. So again, I stated or listed out the method you would do that. So your first radical is half, and your second radical is half. You're gonna take these 2 halves to make a whole double bond. And then your third half is gonna end up lonely. Get it? Like lonely, lone pairs, only one. Okay, I'm a dork, forgive me. So again, you remember how we looked at these as individual lone pairs. I'm saying this one is half, and the lone pair that's closest to it is number 2. So I'm taking the lone pair from number 1, making a half-headed arrow, and I'm taking the one from number 2 and making another half-headed arrow to conjoin them to create a full double bond. But then what happens to this? That means technically, if I take this lone pair, this bond no longer exists. So that means this will be broken, and this lone pair, well, where can it go? It's pretty much just there. But you can't just leave it there and not show an arrow, so you have to show another arrow denoting that it stays there, and that's where your third half-headed arrow takes into account, giving you your new structure of this. Make sense? So again, we'll try that again. This is my 1, my 2, my 3. Take this as the 2 electrons, half here, half there. So those 2 halves make the whole. And then this last one, again, it's just stuck there. So you leave it there. But you will always have to show an arrow to denote that. Make sense? All right, more problems coming up.